Hello everyone, I am Haiyin Che from Institute of Data Science and Knowledge Engineering, School of Computer Science in Beijing Institute of Technology. In this session, we discuss massively parallel processing model for structured data. The data processing system provides big data computing and processing capability and an application development platform. From the perspective of computing architecture, the data processing system is divided into the data algorithm layer, computing model layer, computing platform, and engine layer. Computing models are the way that different kinds of big data is processed in different scenarios, which include batch processing, stream computing, large-scale concurrent processing, MPP model for structured data, in-memory computing model, and the data flow graph model. Now let's look at the third computing model, massively parallel processing, MPP model. In massively parallel processing MPP model, database data is partitioned across multiple servers or nodes, with each server having memory processor to process data locally. All communication is via a network interconnect. There is no disk-level sharing or contention to be concerned with, that is, share-nothing architecture. Big data may be semi-structured or unstructured. The massive parallel processing MPP model architecture structured the big data to enable easy querying for reporting and analytic purpose. MPP systems are sometimes referred to as shared-nothing system. This means that data is partitioned across many servers, also known as nodes, and each server processes queries locally. In the diagram, 4 nodes are using to replace one single server and reduce the query time from 1 hour to 15 minutes. The process begins by the client issuing a query that is then passed to the master node. The master node contains information such as the data dictionary and the session information, which it used to generate an execution plan designed to retrieve the needed information from each underlying node. Parallel execution represents the implementation of the execution plan through the parallel computing of node 1 to node n, and the query result will return to master node. Massively parallel processing MPP is the coordinated processing of a single task by multiple processors, each processor using its own operating system and memory, and communicating with each other using some form of messaging interface. MPP can be set up with a shared-nothing or shared disk architecture. In the shared-nothing architecture, there is no single point of contention across the system, and nodes do not share memory or disk storage. Data is horizontally partitioned across nodes such that each node has a subset of rows from each table in the database. Each node then processes only rows on its own disk. The shared-nothing system with distributed database need a lot of coordination to complete a common task. Each node owns a slice of the database. Managing this database could be very difficult. Shared-nothing systems with the replicated database are not suitable for applications with tremendous data requirements. If the computation needs a lot of data modification, operations like data insertion and drawing, then the shared-nothing architecture may not be viable. Performance through segment instance parallelism, master host and standby master host. Master coordinates work with segment host with one or more segment instance. Segment instance process queries in parallel. Segment hosts have their own CPU, disk, memory in the share-nothing structure. High-speed interconnect for continuously pipelining of the data processing. Architecture of MPP database. There are a master and 4 slaves with 2 segments on each slave and a mirror for each segment on another machine. MPP database architecture. Typical MPP database usually adopt a shared-nothing architecture composed of one master node and n slave nodes. The master node is responsible for interacting with clients, managing the whole cluster, and coordinating the query process. Each of the n slave nodes is responsible for storing a partition of the data and performing query processing on its partition. Each slave node hosts database instance, which will be referred to as segment subsequently. Most MPP databases provide fault tolerance at storage level, a mirror schema. That is, replication is commonly used to ensure durability and availability of data. As the figure shows, each segment, primary segment, is allocated with a mirror segment in another node. The master node detects node failures by monitoring heartbeat of slave nodes. If a slave node stops responding for a certain amount of time, known as a system delay time, normally around 1 minute, the master will treat it as a failed node. Once a failure is detected, the corresponding mirror will be activated to replace the failed primary segment. Similarly, a standby works as the replication mirror of the master node. Through the mirror scheme, the system's availability can be significantly enhanced. However, such a mirror scheme does not support intra-query fault tolerance automatically. When a node failure occurs, the running query's state on the failing node will be lost. After the corresponding mirror is activated, the whole query has to be rerun. If it is a long runtime query, response to the client will be severely delayed. In the worst case, a query will run indefinitely if the probability of failure is high. In massively parallel processing MPP database, data is partitioned across multiple servers or nodes, with each server having memory processor to process data locally. All communication is via a network interconnect. There is no disk-level sharing or contention to be concerned with. That is, it is a shared-nothing architecture. Master hosts separate physical server with its own operating system, CPU, storage, memory. Hosts master database. There is no user data in the master database, but stores metadata about a segment. Think in the terms of system tables. And the second, third, fourth segment host individually physically servers with their own operating system, CPU, storage, and memory. And the host segment database. Each database stores portion of user data, and the interconnect switch Segment server database communicates through an interconnect switch. The main characteristic of MPP database is data distribution. Data is distributed across each segment database to achieve data and processing parallelism. This is achieved by creating a database table with distributed by clause. By using this clause, data is automatically distributed across segment database. In Greenplum, you can either use hash or round-robin distribution algorithm. In this session, we learned large-scale concurrent processing, massive parallel processing MPP model for structured data. Thank you for your attention. If you have any question, feel free to contact me.